Welcome to the course Business Analytics and Text Mining Modeling using Python. This is the very first lecture and we are going to cover the introductory aspects of this particular course. So let us start. As you might be familiar, this course is subsequent to my earlier courses in the data science area. So previously I have taken two courses, Business Analytics and Data Mining Modeling using R, and Business Analytics and Data Mining Modeling using R Part 2. So these two courses focused on the data mining aspects where we work with numerical data which is highly structured in nature, and we apply various statistical data mining and mathematical techniques to solve prediction and classification problems. So in these two courses, as you can see in the slide also, we are talking about the numeric data, very structured and processed using data mining techniques. You might also from first few lectures of these courses you would also get an idea about, especially from the first course, Business Analytics and Data Mining Modeling using R, where we have talked about the variable types like continuous variables, categorical variable, and there we have also discussed about categorical variables and how they are processed in data mining techniques. So typically we use numeric codes to process, to define categorical variables. So so that kind of analysis takes place in data mining techniques, and that we covered in these two courses. Now when we talk about structured numeric data that we have used in the previous courses, it is about uniform measurements taken for all the observations in the sample. So in a tabular format, in a matrix format, we have columns and rows, so variables on the column side and observations on the row side. So for a given column we have to take same measurement for all the observations. So that is how we get our structured numeric data. In this course we progress towards processing unstructured data. Text is typically described, rather it is naturally unstructured data. So we are going to be dealing with text data in this course, and that is why the name is Business Analytics and Text Mining Modeling. So in this course, another thing that is going to be slightly different is the uses of data science platform. So in the previous two courses we had used R platform for performing various exercises, writing our codes and doing our model building process. In this course we would be using Python platform. So Python is as we have talked about in previous two courses, Python is slowly catching up and becoming has already become second most used platform after R in data science arena, and in future it might even overtake R platform. So we are going to introduce Python platform as well in this course, and much of the work that we plan to do in this course would happen using that platform. So as I said, text is typically described as unstructured data. So we are going to model prediction problems using unstructured text data. So we will learn those aspects in this course. Now in our previous two courses we have talked about machine learning techniques as well, for example decision trees, artificial neural networks. Now some of these techniques were earlier employed to model prediction problems using numerical data. Now many of the some of the techniques, some of the machine learning algorithms can also be used to model prediction problems in using unstructured text. So the same thing is mentioned here, that machine learning algorithms can be employed to model prediction problems using data which could be structured numerical measurements as we did in the previous two courses, or unstructured text. That is something we are going to cover in this course. So how this is going to happen, because when you imagine a structured numeric data, you are always going to imagine the tabular format, the matrix format, the columns and rows. However, when we talk about the unstructured data, we talk about the text data. It is series of words composed together to create a text document. So how our machine learning algorithm are going to be used to process this kind of data, where we know that machine learning algorithms, they typically work with the highly structured data. So this is so now we are going to discuss what is typically done to reach to that level where machine learning algorithms can be applied. So the next point is, so how this is possible is because text and documents can be transformed into measured values. So what can be done is, presence or absence of words can be shown on the column side of the tabular format. So any text document, it would be in a sense a composition of a set of words. Now if we are able to identify the unique words out of all the text documents that we might have, and if we are able to show that if we are able to represent those unique words on the column sides, just like we did just like we did for in the structured numeric data set in the previous two courses, where we had variables. They of course most of them were numerical in nature. So on the column side we can have these unique words so in the tabular format, and on the row side for each document we can record whether these terms are present or absent in that particular document. So in a sense we would be capturing the presence or absence of words in all the documents that we might have in our collection. So in this fashion we would be able to transform the text data into a format, into a tabular or matrix format, just like the one used in data mining techniques, and we apply machine learning algorithms. So that kind of transformation can be done, and therefore we can say that some of the machine learning algorithms could be found really useful to solve, to deal with, to process unstructured textual data and solve predictive text analytics problems. So if we do this kind of arrangement where we are indicating the presence or absence of words for various documents, so this will lead us to a common representation used in data mining techniques for numerical data. If we are going to apply machine learning algorithms, and finally the presentation format, the tabular format, the matrix format is going to be used in both text mining and data mining. So we will understand that central themes are going to remain similar. So eventually data is transformed into a particular highly structured tabular form, where machine learning algorithms can be applied. So central themes remain similar in both the domains, text mining as well as in data mining. However, a few key differences are there. For example, evaluation techniques. So these techniques will have to adapt to the chronological order of publication. This is different from the numeric data. We will have to use the alternative measures of error, because the way we are used to in terms of measuring accuracy and error of our models in data mining, that might not be really relevant or meaningful to that extent in text mining. So this is going to be, these are going to be some differences. Now data, text and documents. So some of the specialized techniques which can process this kind of data might be preferred. So this is going to be another key difference. Then when we talk about text data, because even a small document might be having a huge number of unique words, which would essentially are going to be treated as vectors, attributes or predictors. So therefore we are going to be dealing with high dimensional data. So because of that, if we have tens of thousands of words and documents, So we are going to be dealing with we are going to have a lot more number of unique words and therefore attributes, and we'll have to process the dimensionality of the data set would be on the higher side. So techniques will have to be scaled up, will have to be modified to be able to process that large amount of data. So these are some of the key differences that are definitely going to be there. Now there are some other related domains like natural language processing and search engine technology, which are very close to what we do in text mining. However, these two domains, natural language processing and search engine technology, they focus on linguistic techniques. So essence of language understanding, that is very important there, because they are trying to learn from that semantics of the language, and then they are trying to use that in their tasks. So however, because of the increased usage of machine learning paradigm in general, the fields are becoming more closer, and learning from data, whether it is numerical or text, it is becoming more easier. So these fields, natural language processing and search engine technology, which were earlier dominated by linguistics, and with the help of computer specialists, who will help them in terms of processing this kind of data. So now those fields and text mining, they are becoming closer because of the computation abilities that we have and our ability to apply some of the machine learning techniques for text mining tasks. Now if we look at the way text mining is structured, the main theme is very empirical. So we are not going to apply the language understanding like that is done in natural language processing in text mining. It is very empirical theme that we follow in text mining, and that is what it makes closer to data mining rather than natural language processing. So we typically mine for recurring word patterns in large text collections or large collections of digital documents. So essentially, just like data mining, where we are mining numbers, here we are going to be mining words. So we are looking for patterns in words. There we were looking for patterns in numbers. So the main theme is empirical in nature, and there is no focus on the language aspects of the data, which is text. So this brings us to the question how text mining is different. So few more points apart from what we have discussed till now. This is in a sense a progress from applying analytics on large data to big data, because when we define big data, it is not just large data sets of highly structured numeric data, but it will also include so much of textual information, unstructured data in the form of text that is being generated generated in internet, where we have so many of e-commerce websites with comment section, people talking about products, services, commenting, writing blogs, and there are technical websites focusing on the technical content. There is so much of interactive data in the text format that is being generated. So all that is also considered to be part of big data. Now naturally this kind of data this kind of data is unstructured in nature. So we are in a sense progressing, we are in terms of applying our analytics from highly structured data to big data. So that is how text mining is different from others, data mining specifically. So it brings us closer towards big data analytics. So a few points about the big data, the way the nowadays the amount of data that we have to deal with. So nowadays most data originate in digital form due to pervasive use of computers. So few examples are given here. Following activities are being performed electronically: stock trading, earlier traditional way we used to call agents, and they used to help us and do the paperwork for us. So that is more or less gone, and we typically rely on electronic mechanisms to for stock trading. Writing a book, so earlier pen, paper and pencil we used were used to write our our ideas, our thoughts to in a book form. But nowadays we use Word documents, Microsoft Word documents to write our books. Buying a product online, digital transactions. So if we look at the most of the governance space, whether in the private sector or public sectors, we have moved away from the paper based transaction to paperless digital alternatives. So in that sense, digital transactions have increased. Almost most of our transactions are now happening in the digital form. So when most of our activities are nowadays being performed electronically, so that is going to generate a lot of data. And then it will there are going to be services, and people are going to be talking about those products and services. So a lot more text data is also going to be generated. So text mining in a sense is different in a progress towards a step towards progress, in the sense where we are also trying, where we are also making an attempt to analyze the unstructured data. Let's discuss a few more points about data mining versus text mining. So we'll discuss the similarities as well as dissimilarities. So both text mining and data mining, they are about finding valuable patterns in data. In data mining, we try to find valuable patterns from the numeric data. In text mining, we are going to we attempt to find valuable patterns from the text data. So that is the similarity. Now if we look at the data mining domain and analyze how it has progressed, now at this moment it is in its maturity phase. So we are not going to expect any significant development. It might happen, but we believe that it has reached into the maturity phase. And incremental development, of course, that will continue. No longer an emerging economy, so emerging technology. So it is being widely used in industries, and the public sector as well. So incremental development will happen, but we are not expecting very significant things. Techniques are highly developed, as you might have experienced in our previous two courses, where we were fairly sure about what is supposed to be done given a data set, what kind of techniques are to be applied, how the results are to be analyzed, how the results are to be interpreted. Typical data mining modeling process we followed. So many things that we discussed in the previous two courses, they tell you that this field, data mining domain as such, has moved into the maturity phase. It requires highly structured numeric data. So that is true, that we have learned from previous two courses also. Everything is in tabular format. All the variables that we have columns, they are very well defined. How they are to be measured, that is also very well defined. So it, of course, when this kind of we are dealing with this kind of highly structured data, it will require extensive data preparation. So from various sources we collect and gather data, and then we will have to process that, we have to transform that to finally arrive at a highly structured form. So that is very labor intensive effort. So much of what we do in data mining, much time of what we do in our data mining is actually involved in this data preparation phase, because of the requirement of highly structured data. Lacks universal applicability. This is mentioned mainly in the sense that because we would typically be working with the numeric data, which is not the case in the overall big data space that we have. So therefore until and unless we process some of that data, we cannot apply data mining techniques. So therefore there is lack of universal applicability in that sense. Another point which is common to both data mining and text mining is that both domains are about learning from samples of past experience or examples. So in both the domains, we try to learn from the past experiences, past records, past examples that we have. we build our model based on that, and then we try to project our learnings on the new data that we might have to score and that we might have to project. So, in both the domains this thing is common. Now, points specific to text mining domain. This is an emerging area. So, this is though a lot of work has already happened, but this is this particular area is still considered to be an emerging area. And in this we work with large collection of documents. So, documents, when we talk about documents, they are going to be in our spoken language. So, the words, the contents that are there, they are in the form of words which are readable, which are meaningful, which is not the case in data mining. So, we are dealing with a large collection of documents in text mining which have the contents are meaningful, contents are readable. So, it is like numbers versus text. Whenever we talk about data mining versus text mining, it is about numbers versus text in a brief sense. Now, if we look at the task, the kind of task analytical task that we have to perform, they are going to be formulated differently. So, techniques, many techniques are going to be similar in nature, because as we discussed, we even in text mining we eventually transform our textual data, our text documents into a format which is closer to tabular or matrix layout being used in data mining. So, some of the techniques are very similar, but the tasks, the way the problems are formulated, that is different. Now, let us talk about structured data which is typically used in a data mining effort, and the various aspect of structured data, and then later on we will focus on the unstructured data and mainly text. And once we learn this, then we will be able to understand the differences between the two. So, let us start. So, as we have discussed, any kind of structured data, it requires data preparation involving data transformation steps. So, from various sources we collect data, we process them, we prepare and present into finally a tabular or matrix format, as we have discussed. So, much of the data collection effort that goes into this might be based on very careful prior design. So, we might have a business problem, we might reduce our our analytics component from it, and whatever is required, whatever kind of data, whatever kind of variables are required to to model that analytics problem, we try to collect that. So, in a sense there is a prior design in place in our data collection effort when we are trying to gather structured data, collect structured data. Measurements are well defined. So, as we have learned in our previous two courses, the variables that are used in the column side in the tabular format, they are very well defined. We define them properly, and how they are going to be measured, that is also very well defined. So, and the recorded uniformly for every observation in the sample. So, for every observation, for every row, for a given column, for a given variable, in the same fashion we measure that particular variable. So, these variables might also be representing to a higher level concept. So, that concept is to be measured uniformly across the observations in the sample. Now, we look at types of these measurements, types of variable measurements. These are two types, mainly continuous variables, categorical variables. Again, continuous variable continuous variable two types, interval and ratio, and a categorical variable two types, nominal and ordinal. So, these are the types of variable measurements. Finally, we get a highly structured tabular or matrix format. Few more points about structured data. So, now if we look at the rows and column side in a structured data, a row in the tabular format is a complete example of past experience. So, an observation could be about individual, could be about firm, could be about household. So, that is and whatever whatever information is being measured along the column side for different variables, that is going to convey a complete example of past experience. So, that is how row can be described. A column is one measurement taken uniformly for all the rows. So, a column is representing a variable, a predictor, it might be high level concept. So, that is measurements. It is well defined, measurements are taken in a uniform fashion across all the rows. So, all this creates a structured word for applications of data mining techniques, and typically we operate a typical mathematical fashion. We partition the data based on the sample that we have taken. We partition one training partition, we take that and build our model. Then we apply that model to score the test partition and check how the performance is there. Training partition versus test partition and all that. So, a typical step by step fashion, in mathematical fashion, all these steps are performed using various functions that are available in our data science platform. Now, let us talk about unstructured data. So, this is mainly in the context of text mining. So, initial presentation is a variant of XML format. So, of course, when we talk about textual text documents, it is composition of words. So, sentences, paragraphs, all those things are going to form a particular text document. So, it is very much similar to any XML document that we see in the internet. So, now for processing in text mining, this text is transformed into numerical data leading to tabular format used in data mining. So, this is what we have mentioned quite a few times. So, when this transformation is done, when we arrive at a tabular format, so for text, a row is going to represent a document. So, in data mining, typically the row is an observation on individual or firm or industry or country or household. Here a row is representing a document. So, that document is in a sense is an example of a prior experience, and column is going to represent measurements taken to indicate presence or absence of words. So, the words are going to be there in the column side, and the column is going to represent those measurements. So, each row represents a document and each column a word, and now the cells in the tabular layout, they are going to be filled with ones and zeros. So, if that word is present in that document, then 1, if it is absent, then 0. So, the whole the layout, all these cells is going to be filled with ones and zeros, which is slightly different from the layout that we might have in data mining, where actual values, because the variables are representing an actual a higher level concept, and those values are real in nature. Here it is either 1 or 0 indicating presence or absence. So, when we do this kind of transformation to apply text mining techniques, it is very easy for us to understand why techniques similar to data mining can be used in text mining, because we can arrive at the similar kind of format, and these techniques have been found to be very useful. And this goes this is happening, this success is achieved even without understanding specific properties of text, like concepts of grammar, meaning of words. So, without even focusing on the grammatical aspects or the meaning of those words, we are applying in text mining domain our machine learning techniques in a very empirical fashion, and still these techniques have been found to be very successful. So, let us have a look at a binary spreadsheet of words in documents to give you an idea. So, this is one example. You can see here we have first column company, then second column income, third column job, fourth column overseas. So, these are words. So, they might represent variables, but in this case these terms are representing words in our collection of documents, and first row that we have here is representing is indicating whether these words, for example company, whether it is present in the first row, that means in the first document or not. So, it says 0, that means it is absent. Then in the second column we have income. So whether this word income is present in the first document or not. So the value is 1, so it indicates that this income word is present in the first document. So on and so forth. Similarly, for document number 2, for company it is 1, for income it is 0, for job and overseas it is 1. So in this fashion, whether these words as indicated in the column side, whether these are present or absent in the corresponding documents on the row sides, that is how this is being represented. Now in a data mining context, when we are dealing with numerical variables mainly, these values are going to be very different. For example, if income was considered to be a variable, we will have actual income values here like 10,000, 20,000, 5,000, 1,000. So those kind of numbers we will have. These numbers are quantification of the income, they signify something. Here these are just words and we are just indicating the presence or absence. So this is a very rudimentary way of representing our collection of text documents. But even with this, when we apply machine learning algorithms, we get very successful models. So in text mining, words are attributes or predictors and documents are cases or records. Together these form a sample of data that can feed our well known learning methods. So learning methods, supervised, unsupervised learning methods that we have learned in previous 2 courses. So this kind of arrangement can be used to apply some of the methods that we have used in the previous courses. Machine learning techniques can be used to work with this format and process large amounts of data. Now let us discuss few points about machine learning techniques in general. So how we can describe machine learning techniques? They can be described as statistical techniques without prior knowledge. So in statistical techniques, we are always going to make certain assumptions about data, variables, and how they are going to be related, and based on that, based on certain rules, we do our modeling. So but in machine learning techniques, we don't make those kind of assumptions about the structure of the data, and we try to process a massive amount of data and try to counterbalance that lack of assumptions. So that is why we can refer machine learning techniques as a statistical technique without prior knowledge. So we are not assuming anything about the data, we are trying to learn whatever is there from the data itself. For example, if we take this statistical technique multiple linear regression, so it is going to assume the linear relationship between y target variable and x's, which are predictors. So between y and x's, we are going to assume linear relationship in multiple linear regression, which is not the case in the machine learning techniques, where we are whatever kind of relationship is there, it has to be learned from the data. So we don't make a priori assumptions about those structures. So but lack of these assumptions might create certain deficiency in machine learning techniques, but that is very well counterbalanced with massive processing of data. So essentially we are finding, in using machine learning techniques, we try to find patterns in word combination that are recurring and predictive. So any patterns that can help in our prediction task, so that we are always looking to identify using machine learning techniques. Now to further understand the difference between the unstructured data and text data, numerical versus text, let us understand few text characteristics. So if we given a collection of documents, the set of attributes or predictors set of attributes that we are going to show in the column side, they are going to be total set of unique words in the collection. So in the collection we might have tens of thousands of documents, and those documents are going to be composed of a set of unique words. So these set of unique words are going to be set our set of attributes that is going to be used for our analytics in text mining. So for thousands or even millions of documents, essentially, so this set of attributes is also referred as dictionary, and when we are dealing with even when we are dealing with thousands or even millions of documents, this dictionary will converge into a smaller number of words, because there can be if we look for meaningful words, there can be very a limited number of words as we can see in any dictionary belonging to any particular language. So eventually irrespective of the number of documents that we are dealing with, we will converge to a smaller number of words. However, there might be situations where this thing might not remain practical in terms of number of words that we will have to deal with, number of attributes that we might have to deal with in text mining when we are analyzing technical documents, because technical documents are also going to include the alphanumeric terms. So therefore the dictionaries, the size of dictionaries can be very large, and therefore the layout, the tabular layout is going to be very large in size, and therefore it might not remain practical to process it. So this also can happen in the text mining context. So there are a few more characteristics of there are a few more characteristics that we would like to discuss, which will make it easier for us to process data. So we will stop here and we will discuss some of these characteristics in the next lecture. Thank you.